In this video, I'm going to demonstrate how to connect a Raspberry Pi to the Connecting platform. We're going to follow the instructions on the manual as we see in front of us. And we have a login to, in this instance, this server, demo.connecting, but you may have your own. You may also have your own username and password. So to get started, any Raspberry Pi will do. Have it plugged into power and the HDMI cable connected to a monitor. That would allow you to see the IP address it gets when it's connected to the network. Then we need to type into the Raspberry Pi. So for option 1, you can connect a keyboard directly, or if for option 2, you can remotely log in. For instance, in Windows, we can use the program PuTTY to do this, and I will demonstrate that now. So I open the program PuTTY, type in the IP address that appeared, use the default port and SSH, and click Open. You log in as the username Pi and use the default password, or if another one has been set. So once we log in, we get the introductory messages, and we are now at the current working directory of the home directory for Pi. So now we're typing in to the Raspberry and we can issue the commands. So for the first part, we want to download and install the basic programs. We can just copy paste these 3 lines into the Raspberry Pi, and that should do it. So the first one is to do a git clone. That pulls down the scripts from the GitHub account. It creates a directory called IoT-Raspberry Pi, so we cd into that directory, and then we run Python for setup.py. This initial script will set up what we need to point to the server. So firstly, it asks, what is the server location? So you type in your own one, but for this instance, it's demo. Press enter. What is the name of the device? So this Raspberry Pi, for instance, I'm going to call PI1. It needs a username. Now this is the username for logging into the Connecting platform. So we can see that here. I'm going to log in as demo Pi. Okay, so initially we can see the output. This script, the setup.py script, has created a device on the server and then created a series of metrics on the server, such as Pi CPU load, Pi uptime, etc. So now the program has ran and set up. What we would like to do now is run the basic program. So if we run this one-liner to Python Pi IoT.py and click enter, this Python script has captured some metrics from the Raspberry Pi, sent them to the server. So we can see very explicitly what the message and the datagrams being sent to the server are. By the way, it also took the IP address that we're at and made an attempt to guess what the latitude and longitude is. The 4 metrics we sent are the Pi uptime in number of seconds, the CPU temperature, the CPU load, and the RAM free. Then it paused for 30 seconds and then it does the same again. So I can leave that script running, and on the instructions we will see to create a dashboard on Connecting so we can see the data. So on the computer, this is the machine here, we're going to go to the applications on the left menu, click application, add application, and give it a name. So for the first step here, we log in to Connecting. It initially brings us to the applications page, and the instruction was to click add application. We can give it a new name. For example, I'm just going to call it Pi1. And a URL, you can give it anything, Pi1, the same as the name will do. I'm going to enable geolocation, leave that ticked for now, and click create. So now we have an application called Pi1 and a selection of buttons to go with it. I could view the application, but edit app is what I really want. Click on edit the application. So this is like a dashboard. And we are on the home page. We can create new pages on the left here. On the bottom right, we have the ability to add a widget, and that's to add a thing like a graph so we can populate this dashboard. It's currently very empty. So let's go ahead and click Add Widget. So now we decide what type of widget would we like to add. In the instructions, it says to click a simple line graph. So I'll do that here. The simple line graph is the second available one. By the way, there are lots of other types. Even choosing a different category will give a different selection of outputs. So anyway, I click simple line graph and choose select. I am now at the settings page for this widget. Looking back at the instructions, I will choose to graph the metric pi uptime. So that metric was created by the setup program initially. So I'm going to give the pi uptime label on the top left for this widget. On the left side we see the widget in preview mode, and on the right side we get to set what the settings are for this widget. The only setting of importance really is that we select pi uptime in all of the metrics. So I've scrolled down to pi uptime and I click that. Time buckets, we can leave it at auto if you wish, but just for the sake of it I'm going to click raw data right here now so we can see, and then click apply settings. The raw data will allow me to see one of each of the data points as they were uploaded. And click finish. Now it'll bring me back to the application page and the widget will be inserted. Here in the applications page with the pi uptime widget just loaded now, this is the new widget we've inserted. We can see two data points in it so far at 84,448 and then 30 seconds later. This corresponds to how every 30 seconds the script is uploading the current metric, i.e. how many seconds has this Raspberry Pi been powered on for. And that will continue to rise 1 second in real time and is getting reported every 30 seconds. So that explains why we see two data points separated by 30. I can resize this widget if I wish. I'm going to make it slightly smaller vertically and click the horizontal and make that smaller as well. Now we can look at the instructions and it will say to make another graph for each of the metrics for pi CPU load, pi CPU temperature and pi RAM free. So that's the same procedure. Add widget on the bottom right. You choose the simple line graph and in the settings set the metric as we described. So for the metric pi RAM free, I'm going to select the raw data for settings and I'm going to set the menu on the top left, the header to say RAM free. This is how much RAM is free on the Pi. Click finish when I'm done. And now that widget has been inserted into the dashboard. I'm also going to resize it vertically and horizontally so that they fit a bit neater. Okay, so we now have two metrics streaming from the Raspberry Pi every 30 seconds, and they're currently displayed on the dashboard on the home page. I'm now adding the third metric, Pi CPU temperature is the third metric I'm adding. Be sure to click Apply Settings on the bottom right and get the Configuration Save Successfully message, and then it's safe to click Finish. We return to the main dashboard. I could leave this graph at the following width as we see it here, perhaps just make it slightly less vertical, or you can resize to whatever suits your needs. There was one other metric that I wish to chart here, another simple line graph. I'm choosing simple line graphs here, but of course you can choose any of the various ways of displaying this information. There are lots of dashboard templates available. Other graphing mechanisms may suit whatever you want. So the Pi CPU load was the last metric I wish to show. And click Apply Settings, bottom right. And I'll change the naming across the top, the label for it to say CPU load. So that widget now gets inserted, and I'll also resize that so it just takes up a quarter of the page. Okay, so at this point now, we have a nice dashboard, a single page, the home page, showing 4 different graphs, showing 4 different perspectives of the Raspberry Pi's metrics right now. We can see that the uptime is increasing steadily. The RAM free is staying stable. And the CPU temperature is moving up and down perhaps a degree or so. And the CPU load, of course, changes over time depending on what it's doing. So I can just take a look at the Raspberry Pi over here, and I see my script is still running. It pauses for 30 seconds after it's captured each of the metrics. As a by-the-by, it is sending longitude and latitude figures. It guessed those by taking the IP address that the Raspberry Pi has as it sees the internet, and then says from a geolocation service where that might be. Looking across the top of the dashboard page, we see the filter bar. Here I can select which device I'm interested in. Of course, today I have just created Pi 1, just this one new device, so that's the only one I can see. But if there are others, we could choose which device we want to see the metrics for in this dashboard. And also we can choose different time ranges. At the moment, I'm only concerned with the latest information, so by default, it is showing the last 24 hours worth. Across the top as well, I could also click the map icon. Doing so will show me my Raspberry Pi on a world map using the latitude and longitude which it is uploading here. So this is just a rough guess as to the location geographically of where it is, and is dependent on what the IP address I said was. But we're finished that now, so I'll return to the applications page. I see my Pi 1 application there. So we have created the dashboard on connecting to see the data. The Raspberry Pi is streaming the information to the server, and we can see it on the dashboard. The next step is to add an air sensor to the Pi. So the image shows the construction of what we're doing here. There are 2 major elements. The sensor for measuring temperature and humidity is the AD2032 device, and I'll give a link later to show where you can get one of those. And then an LED on the left here as we see it. The 2 of them are connected to the GPIO pins on the Raspberry Pi. This Raspberry Pi shown here is connecting to the internet using a Wi-Fi dongle here, but depending on which variation of the Raspberry Pi you have, you could have that built in, or you could use the Ethernet, for example. This one, because we're remote logging into it, is just needing the Wi-Fi and doesn't need the HDMI cable to the left because we know the IP address. So scrolling back to where we were, we see that the 3 points here list where the wires go from and to. So the GND on the sensor goes to the ground pin on the Pi, the VCC goes to the 3.3 volts, and the SIG signal goes to the GPIO pin of pin 7, which is known as GPIO 4. So on the bottom right, we can see the green wire coming out of GND, the red wire coming out of VCC, and the yellow wire coming out of SIG. If I scroll down, we can see what those pins are called on the Raspberry Pi. So when I said that the VCC should go to pin 1, that's the top left pin, and it provides 3.3 volts of DC power. It's known as pin 1, and you can see how they increment here. Pin 1 on the left, pin 2 on the right, then 3, then 4, 5, 6, etc. So after connecting the wires as we've seen them here, in particular the AD sensor, we need to run a program to read those values. Looking at the instructions, we merely have to type the following. We can copy paste them in. So I copy. Now the putty session is still running. We could leave that running if we wish and open up a new putty session, or if we wish we can hit Control C to break that current program that's running and paste the new one. This script will install the necessary programs, so it may take a minute or two to pull them all down from the internet. While that's running, I'll copy the next command from the instructions. Control C to copy. And paste this script in for sudo python pi-dht.py. So it gets the latitude longitude again, and now it's going to attempt to read the humidity and temperature using the sensor through the GPIO ports and capture that. Then it will send them to the Connect Things server if it can. This may take a moment, especially for its first reading. So running the program for pi-dht.py, it gets the latitude, longitude, and makes two sensor measurements, the temperature and humidity. It sends those both to the server, one each. First, the value of the temperature, and then the value of the humidity. It pauses for 30 seconds and will send them again. So with those two new pieces of data being sent from the Raspberry Pi to the server, we can add them into the dashboard. So on the applications page, I could create a new application, or I could edit this application and add two new widgets here. Just for the sake of it, I'm going to add a new page to show the air sensor data. Click plus and it'll create a new page. And now it will be a blank dashboard again because we're on the air sensor page. I'll add the widget this time for the temperature as gathered by the air sensor. So we select, this is just another simple line graph. And on the top left, I'm setting the title to air temperature. The metric is going to be the one that was created, pi temperature, not pi CPU temperature, which was the CPU of the Raspberry Pi. This one is the air sensor, and I'm going to show the raw data here again. Click Apply Settings, and now I can click Finish, and we'll return to the dashboard. Going to make it narrow and add another widget. Another simple line graph, click Select, and in the settings I'm going to choose the metric for pi humidity. Scroll down and find the pi humidity. Set the time bucket to raw data and click apply settings. I see it was saved successfully, and I can change the title. Click finish, and now the widget will be inserted into the dashboard page. I can narrow it up and put the two on the same line. Okay, so now here we see the two metrics coming through from the sensor which was attached to the Raspberry Pi, and they're being graphed on the dashboard. If we want, we can choose different time ranges, etc. And of course, all of these graphs are completely configurable, and we could download all of the data in CSV or PDF, etc. But right now I can see where each of these data points corresponds to 30 seconds, which is what's happening in the console as I can see it here. The last part was to produce an LED to indicate the temperature, and this script is already doing it. This video shows what's happening with the LED. We can see it is flashing brightly with the high temperature, and there are three settings for the LED. It will show fast flashing if the temperature is above 25, medium if it's between 20 and 25, and low below 20 degrees. It will just flash slowly. So that LED is a demonstration of showing outputs locally on the Raspberry Pi based on metrics collected by the sensors. So the rest of the documentation here shows the GPIO pins for reference, so that when we were connecting the wires, as we saw in the earlier stage, here are the pins as they entered the sensor itself. We could see green going to ground, red going to VCC, which is 3.3 volts on the Raspberry Pi, and the signal going into the GPIO port. Looking at the overall picture as well, we could see that the green, as described in the documentation, goes into the short leg of the LED, and the long leg of the LED goes into a 470 ohm resistor, and then into the blue cable as we see it here, which also goes into a GPIO port. This description is listed here. Pin 13 on the Raspberry Pi, for example, corresponding to GPIO port 27. So in summary, what we've seen here is that this Raspberry Pi was attached first on its own to the connecting server and was streaming 4 metrics about itself: the CPU load and CPU temperature and the RAM free, etc. And then with a air sensor, the AD2032 in this example, was connected to the GPIO ports in order to capture the air temperature and humidity and send it to the connecting server. And an LED was also connected to a GPIO port. And in combination with the two scripts, IoT Pi and the DHT script, it was able to make those readings, capture them, send them up to the connecting server, and in the 2 pages of the newly created application, we can see the dashboard demonstrating all of these numbers. Thanks very much for listening, and if you've got any questions or concerns or feedback, please get in contact with us at support@davra.io. Thank you very much.